On to topic 4 of chapter 4, absolute value, equations, and inequalities. The key to absolute value is that it's always going to be its positive value. And there are a few techniques that we will go over as we go on. So, the absolute value of x, denoted by this symbol, is defined as whether or not x is positive or negative, it comes out of the absolute sign as a positive value. So when x is non-negative, the absolute value of x is x. When x is negative, the absolute value is the opposite of whatever negative value there that makes it positive. So, find the solution set of this. Now here, the positive value of x, or the absolute value of x, is 6. What could have been here? Well, you could have had a positive 6 there, or a negative 6. And for this one, the absolute value of 0 is 0. Now, C is something you might find every once in a while, and it's a little tricky. Because what are they saying? The absolute value of something is a negative something. Again, that's impossible. You can't have that. So this is no solution. So for A, it could be either negative 6 or positive 6. For B, there's just a 0. And for C, since it has to be positive, you can't have a negative. It's an empty set. There is no solution. So here's sort of a summary of what we've just done. All right, now we get into the meat and potatoes, so to speak, of what we're doing. And what is the strategy for doing these? Well, the strategy for doing them is, first of all, you remove the absolute sign and just set it up. 2x plus 1 equals 5. Or 2x plus 1 equals, now remember that could also be negative, a negative 5. Now remember, if that was a negative 5 there first, there would be no solution. We're saying what's in here could have equaled a negative 5. So we just solve them. 2x, transpose the 1, that gives us a negative 1 on this side, so that's 4. X equals 2. Or here, we're going to transpose that. That gives you 2x equals a negative 6. Since on this side it becomes a negative 1, x equals negative 3. Now, when you see something like this, that the absolute value of something is equal to a negative, no solution, or it's an empty set. And the key is to set it up as two equations. I usually do this one first, but it could also be this. This could have equaled a negative 5. So there are your two solutions. X is a negative 3 or X is 2. Now in this case, as we said, can you have an absolute value of something equal to negative? Notice the absolute value sign is still there. So no solution, it's an empty set. Okay, here they're setting this up in function notation, where they're going to say that this, all of this, is going to equal 11. And let's get it started off here. And we'll use what they've written here because they've done a good job. So again, they're putting what we had here equals 11. Now, the first thing we're going to do is get this negative 4 to the other side. Here it becomes a positive 4. 4 plus 11 is 15. Again, we want to isolate the absolute part. So what do you think is our next step? Yes, we're going to divide both sides by 3. So we then get this. So we've done all of this to hone this. Now we're going to take this, equal it to 5. This, equal it to negative 5. Again, we're removing the absolute signs, equals 5. Remove the absolute signs, equals a negative 5. So there's one, and there's the other. Now notice here, x is going to equal a negative 10. Here, when we subtract 5 from both sides, x equals 0. But again, this is the protocol. You set it from this form to equal first what's there, and then with the removal of the absolute signs, equal to the opposite sign, a negative 5. And here we're considering the absolute value of this equals the absolute value of that. That is, they're the same distance from 0. That's what we're saying. So what are we going to do here? Well, in the first case, we're going to take away the absolute signs and just have this equal that. And then we're going to write or, take away the absolute signs, but put a negative after we remove these. So this becomes a negative 8, and this becomes a negative 4x. So again, this equals that. We've just removed the absolute signs. Or we remove the absolute signs from both. They're putting a parenthesis, which is a good idea, around the second set of terms and a negative in front of that. So this will be a negative 8 and a negative 4x, as we said. Then we solve each equation. And I guess they're missing a slide because they're not showing us the results. But that's the technique of doing it. In fact, let me go back and solve that for you. Don't know if we lost the slide somewhere, but that was missing. So here, we're just going to transpose the 3x. Here it becomes a negative 3x and a positive 4x is our x. The positive 8 on this side becomes a negative 8 and a negative 5, negative 13. So this is one part of the solution. And here we change signs. Now we're going to be doing something with inequalities. So they're not equations. One thing you should remember is whenever you're going to multiply or divide by a negative, you have to reverse the inequality sign. Okay, otherwise, much of it is the same. So what do we have here? Well, this is pretty straightforward. We're going to get x is less than 3, or x, now we have to reverse that inequality sign, is greater than negative 3. So we're making this a negative. The rule is we reverse that sign. Now we have to graph it. So there's our number line. The numbers we're interested in is a -3 and a 3. And what does this say? Well, it says x is less than 3. So we have a parenthesis here. And this says x is greater than a -3. So even though we're saying the word or here, I think when we have the inequality sign this way initially, we get actually it should probably be an and here. I just put that word in from tradition, but I think instead of an or, we need an and. This, I believe, is the answer. Let's go on. Yep. So they're writing it out as we did. And the set that makes it true is an intersection. So this is a conjunction. When x, absolute value of x, is less than something, our answer is going to appear in this form. Notice in interval notation, it matches our graph. Okay, now they want us to do this. And they're not giving us much room, but I'll make some room. So it's going to be x is greater than or equal to 3, or x is less than or equal to -3. And now we'll graph it. The numbers we're interested in is a -3, and this is a 3. And what are we going to use there? Well, this one, it's x is greater than or equal to 3. So a bracket going like so. And this one, x is less than or equal to -3. So a bracket like so. And I think we've learned something. When the inequality symbol is this way, that it's a greater than, you get a disjunction. There's no connection. But since it's a union, when we write our interval notation, we write it as we did before. This is coming from -infinity up to and including -3. That's the bracket. And then the union symbol starting at 3. 3 is included, bracket, and then off to positive infinity. And there's the graph. And again, from the graph, interval notation works so well. Okay? So I had kind of forgotten a little bit that when we are doing something, and let's take a look at this. When we graph an absolute value problem and it's an equality, you're going to get dots. When it's a less than, you're actually getting an and, that is an intersection. And when it's a greater than, you're getting a disjunction, but that's a union as we give it. So again, this is an important slide here to get mastery of these skills. All right, so let's do this one. Now, this is less than, so this is going to be an and. So we'll get the vocabulary right. So 3x plus 7 is less than 8. And 3x plus 7 is greater than negative 8. So again, when we fill that in, it's going to be something that looks like this. This is an AND. So let's solve it. So we're going to bring this over, and we get 3x is less than 1. X is less than 1/3. And here this is going to be 3x is greater than negative 15. X is greater than negative 3. So we make our line. The numbers we're interested in is a negative 3 right over here, and a 1/3, which is about right there. And here we're going to have x is greater than negative 3, so the arrow goes this way. And x is less than 1/3, so the arrow goes this way. And we fill it in this way. And our interval notation for this is negative 3, comma, 1/3, comma. And our set builder notation would be brace. X is such that negative 3 is less than x is less than 1/3. Okay, that looks pretty good. Again, I'm rushing through it just a little bit, building on skills hopefully you have. Once again, we have learned that when it's less than, it's an and. So this would be intersection. That is a conjunction. And we take away the absolute signs, write it just like that. Take away the absolute signs, reverse the inequality sign, and produce the opposite of 8. Solve each inequality, and this is what you get. Okay. Now another way to do it would be this way too, setting it up as a compound inequality here, and we get the same answers. There's the set builder notation, and there's the graph. And that winds up this section. We did it pretty well, just under 20 minutes. Now keep in mind, I do have some additional examples from the ones that are offered in MathLab that you can work. I've done a whiteboard lesson of that and a program like this of those as well. But this is the background.